What's poppin', dogs? Mr. Allen here with some ACT math prep. Got a bit of a mishmash of different types of problems here in this video, but I think they're all gonna be pretty darn helpful. Starting with that first one, which deals with percents. I always see these percent problems on ACT practice tests and the actual one, so let's check it out. So if 115% of a number is 460, what is 75% of that number? Well, you can set this up in a few different ways, but honestly, I like proportions for this one. So I have 115% of a number is 460. I want to figure out what 75% of that number is. Let's just cross multiply and solve. I'm going to bust up my calculator for this one here. We got 115 times x, then 460 times 75. So we get 34,500. 34,500 equals 115x. Let's divide that by 115 now. Divided by 115. Hit enter. We get 300. Boom. That is choice G. It's dope. And there's a couple different ways of setting that one up. I personally like proportions because proportions can be used in a variety of scenarios. Maybe another one will come up here in a little bit. So this is a problem you may not have seen before if you're currently an Algebra 2 student, because it has to deal with trigonometry, but on the unit circle, not so much your right triangle SOHCAHTOA type stuff. It says, what are the values of theta between 0 and 2 pi when tangent of theta equals -1? First off, what is this 0 and 2 pi? That's radians. So I'm going to suggest you guys bust out your calculator on this one, hit mode, and then go down to radian, okay? So I'm going to hit second quit, and now what I'm going to do is I'm just going to type in tangent, and then let's test out pi over 4. So second pi divided by 4, close my parentheses, hit enter, I get 1. Okay, so it's not going to be that one because it needs to be -1. So it can't be this guy, which has pi over 4, and it can't be this guy because it has pi over 4. Now let's try another one, all right? So let's try the 3 pi over 4, shall we? And you can just do tangent, 3 times pi divided by 4, close them, hit enter. Ooh, I got -1. So that's good. So it can't be J now. I'm down to just two choices because it's got to have the 3 pi over 4. So it's either 5 pi over 4 or 7 pi over 4. I'm going to go in order here, okay? So we'll try the 5 pi over 4, and check this out. You can actually arrow up, copy down, and just change that 3 to a 5. Kind of handy. I get +1, so now let's try 7 just to be safe here, because I'm looking like it's choice H right now. Hit enter, and boom, there we go. So I've got choice H for this one. I had no idea really how to do the math on this, but I did in my calculator, and I knew to go to mode. Let me pull that back up here so you guys see it. Mode, arrow down twice, that's radian. The majority of your problems are going to be in degrees, so I'm going to go back to degrees, but you can change to radian mode if you see those radians. 0 to 2 pi is radians, so keep that one in the back of your head right there. But choice H is my answer on this one, and that's awesome. All right, this one looks intimidating. We have a trigonometric function with equation y equals a sine of bx plus c, where a, b, and c are real numbers, just like integers, fractions, could be anything, is graphed in the standard xy coordinate plane below. The period of this function f of x is the smallest positive number p, such that f of x plus p equals f of x for every real number x. One of the following is the period of this function. Which one is it? Whew. All right. Well, again, you may not have seen trig functions at this point. We covered at the end of the year for us, so our kids don't see this until after they've already taken the ACT, unfortunately. But I'm going to help you guys out, and hopefully you'll remember this one. The period is just how often it repeats. That's what they're saying here, is that when I shift this graph, it equals itself again. So how often does it repeat itself? That's hard to see there in that function notation, but that is what that means. So when does it repeat itself? Well, I can look at all my high points to high points. Whoops, skipped one there. All these high points, it's repeating itself again. It goes from high to low to high, to low to high, to low to high. Just keeps on repeating itself. So how often does that happen? Well, let's look at just these two right here. And if I zoom in, I can see that that's happening at 0 and then at pi. So it happens over a distance of pi that it's repeating itself. And then to the next one, 2 pi. So 0, 1 pi, 2 pi, 3 pi, so on and so forth. My answer here is going to be choice B, pi. That's my period. That's about it for that one. All right, we got some logs now in this one. The value of log base 5 of 5 to the 13 over 2 is between which of the following pairs of consecutive integers? Oof, that's a whole lot here. Really, we're just asked to evaluate this thing in between which two is it. Now, if you know logs, there are some cool log properties here. What I can do, I'm going to rewrite this log base 5 of 5 to the 13 over 2. I can take this coefficient, this exponent here, and rewrite it as a coefficient 13 over 2, and then I have this log base 5 of 5. Well, log base 5 of 5 just is evaluated as saying 5 to what power is 5? Well, 5 to the first power is 5. So now I have 13 over 2 times 1, right? So 5 to the first power is 5. And 13 over 2 times 1 is just 13 over 2. Well, that's what, 6.5, right? 12 divided by 2 is 6, so 6.5. So we look at, we're looking like choice D right here between 6 and 7. But what if you didn't know all that log math, right? Or you just forgot it, whatever, you haven't gotten to it yet. Some curriculums get to it by the ACT, some do not. It just all depends on when you take it. So let's bust out that calculator. You can actually type this in. So you're going to hit math, then the green alpha button, then math, and it will bring up any log base. And you can type in 5, you can type in 5 again, and raise it to the 13 over 2, hit enter, I get 6.5. Easy as that. So your calculator can be your best friend, especially in a pinch there, but that one will help you guys evaluate that if you didn't know your fancy little log properties like I just showed you. But I would be remiss if I didn't actually show you the nitty-gritty math as well as the calculator hack to get you by on that ACT. All right, Uno Mas here, guys. Thanks for sticking around. If you are still here watching this video, we got Kareem has 4 sweaters, 6 shirts, and 3 pairs of slacks. Who calls pants slacks? I don't know. But how many distinct outfits, each consisting of a sweater, a shirt, and a pair of slacks, can Kareem select? Okay? So we're looking for how many combinations of different outfits, essentially, he can make. Well, you'll see this one. I see it almost on every single ACT, and it's actually a super simple problem. I'm just going to do 4 times 6 times 3. That's going to tell me what it is. And just to be safe here, let's type it into our calculator, not make any stupid errors. We get 72. The choice here is J, and that's it. All right, they will throw those at you, whether it be outfits or sometimes it's like different combinations of types of sandwiches or meals you can get with different drinks and stuff like that. But there's always seems to be one of those bad boys on there. It's the fundamental counting principle if you'd like to look it up and learn a little bit more about it. It's kind of cool. All right, well, thank you guys for watching. Really appreciate it. Good luck on your ACT. If you have any questions, pop them in the comments. Let me know. I'm happy to make a video for you guys to try to answer you in those comments. Otherwise, have a great day. Good luck studying and crush on the ACT.